All right, so now we have come to an end of the lecture. So let me just quickly summarize what we have seen today. So a decision tree is an easily interpretable non-parametric model suitable for both regression and classification. So it's easy to interpret, and it can also be used to estimate importance of variables. But its disadvantage is high variance, right? So random forest is an ensemble of many decision trees, and it is constructed in a clever way to reduce variance. So, which is why random forest is such a strong algorithm in practice. It's very, very powerful. So, variance is reduced because in the construction of each tree, we only use a subset of all predictors. But at the same time, because of that, it means that a random forest cannot be interpreted directly. It just doesn't make sense. So even looking at an individual tree in a random forest, it does not make sense to try to interpret it because for each split, it is only allowed to use a subset of all predictors, right? So, but what a random forest does, a random forest can evaluate importance of variables, right? So you cannot really directly interpret it, so you don't really understand, why random forest makes this or that prediction. You cannot really follow it manually, but you still can say which variable is kind of more important for the for predicting, and which variable is less important for predicting. So this is random forest, and the out-of-bag error in a random forest is an alternative to cross-validation error. Right? So out-of-bag error is the following thing. So when we train a random forest, we train a lot of decision trees. Each of them is trained on a bootstrap sample. So which means that some observations are not going to be included into this temporary training set for each decision tree. So the out-of-bag error is the error of that decision tree on observations that were not included in that training sample. Okay, and finally, this is the checklist of all the concepts. So regression tree, pruning a regression tree, so metrics for classification tree, and so on. So, and finally, random forest. So this is the end of this lecture.